So, ladies and gentlemen, you are all welcome to my YouTube channel. So, today we are going to look at the concept of electrochemistry. And what is electrochemistry? Electrochemistry is a branch of chemistry that deals with the study of how chemical reactions are combined into electrical energy. So, generally, we know that in a living organ or in a living generally in chemistry, we have different types of reaction. So in electrochemistry is when it's when a chemical reactions are converted into electrical energy. So it's a branch of chemistry that involves the use of spontaneous chemical reactions to generate electrical energy, and that is what describes electrochemistry. So when you need a chemical reactions, like for example, let's say you have zinc 2 plus react with copper to produce copper 2 plus zinc. So if this reaction is used now, this chemical reactions to generate electricity. So that is what describes electrochemistry. So it's the use of a chemical reactions to generate electrical energy or to generate electricity, and that is what describes electrochemistry. So in this class or in this video, we are going to look at the different aspects of electrochemistry. We are starting with redox reaction, galvanic cell. For now, let's start with the redox reaction. Let's start with redox reaction. Redox reaction. What is a redox reaction? So a redox reaction is a reaction that comprises two different reactions. The red here stands for reduction. Then the ox here stands for oxidation. So red means reduction, ox means oxidation. So now let's look at the concept of oxidation and then reduction individually. So red means reduction and ox means oxidation. What is oxidation? Oxidation is the loss of electrons. Oxidation is the loss of electrons. While reduction is a gain of electrons. So when you have a loss of electrons, then we have oxidation. And when you have a gain of electrons, then we have oxidation. So let's demonstrate this definition. Let's say now we have zinc plus copper 2 plus to give us or to generate zinc 2 plus copper plus copper. So now let's look at this reaction and then demonstrate the concept of oxidation and reduction. So look at it here. Is zinc here have a 0 electrons. It means that it doesn't give out any electrons. So but here the oxidation number changed to +2. It means that zinc from here to here, it loses an electron. So from here to here, zinc loses an electron. So it means that from here to here, there is an oxidation because initially it is neutral, and of course after it's give out it is 2 electrons, then it now become zinc 2 plus. So it means that zinc here undergo oxidation. It undergoes oxidation. And of course copper from here to here, because the oxidation number here is +2, and then here is, it means that from here to here, zinc gain 2 electrons. So it gains 2 electrons. So zinc gain 2 electrons. Because it gains 2 electrons, it means that it accepts electrons. So as a result of that, it means that copper plus undergo reduction, because it gains 2 electrons to become neutral. So we also have another way of defining oxidation and reduction in terms of the electron transfer. Sometimes we'll be asked to define oxidation in terms of electron transfer and reduction in terms of electron transfer. So one, you can define oxidation as a loss of electrons, and reduction is defined as a gain of electrons, and that is definition of oxidation and reduction using electron transfer, or in terms of electron transfer. And in addition, you can define reduction. You can also define reduction. You can also have another definition for reduction, where you can say reduction increase. Sorry, is a decrease, involve a decrease. It involves a decrease in oxidation number. Decrease in oxidation number. So you can define reduction as a decrease in oxidation number. So let's look at whether from here to here there is a decrease in oxidation number. So from here the oxidation number is +2, and then here is 0. So it means that the oxidation number decreases from +2 to 0, indicating that there is a decrease in oxidation number. And that is why we said copper from here to here, it undergo reduction. Then we can also define oxidation as an increase in oxidation number. It's an increase in, this one is decrease in oxidation number, and this one is increase in oxidation number. So let's see if from here to here there is an increase in oxidation number. Zinc here have 0 oxidation number, and then zinc here have +2 oxidation number. So it means that oxidation number here increase from 0 to +2. So it means that there is an increase in oxidation number. So this is also another way of defining oxidation and reduction. So you can define it as an increase in oxidation number or decrease in oxidation number. Okay. So we also have what we call oxidizing agent and reducing agent. So let's look at how we can differentiate the two. The oxidizing agent, oxidizing agent, and reducing agents. So we have what we call oxidizing agent and reducing agent. So what is the difference between oxidizing agent and reducing agent? Oxidizing agent is a substance that is any species that accepts electrons. So it's an electron. It's an electron acceptor. While reducing agent is an electron donor. It's an electron. Is an electron donor. So oxidizing agent is an electron acceptor, while reducing agent is an electron donor. So let's look at how we can describe electron donor and electron acceptor in a chemical, in a redox reaction. So let's say we have zinc. So we have zinc plus copper 2 plus give us, or to generate zinc 2 plus copper. So now let's ask ourselves this question. which among these species is an electron acceptor and electron donor, or which one is an oxidizing agent and which one is a reducing agent. So I think it's simple. From here, zinc donates 2 electrons. From here it has 0, but here it has 2 plus. It means that it donates electrons. So here it means that zinc is a reducing agent. And of course, copper 2 ions from here to here it accepts electron. So it means that copper here is an oxidizing agent because it accepts electron. So it is an oxidizing agent. So this is what we call reducing agent and oxidizing agent. So ladies and gentlemen, let's now look at how to balance redox reaction. So now we are going to look at balancing redox reaction. So we'll be given an equation of a redox reaction and you will be asked to balance the equation. So if you have the equation, the first thing, actually there are rules. There are rules in balancing chemical equation. Although it depends on actually the type of a redox reaction. Is it in acidic medium or in a basic medium? So the way you are going to balance the redox reaction in acidic medium is different from the way you are going to balance the redox reaction in basic medium. So now let's start with the balancing chemical equation in acidic medium. So generally the first thing, if you have the equation, let's say this is our equation. We have Cr2 or 7Q minus plus C2 H5 OH give us Cr3 plus CO2. So let's say we have this equation, but in acidic medium, and we are asked to balance this equation. So the first thing that we should not actually forget is that we have to divide the equation. Although we have different ways of balancing chemical reaction, balancing redox chemical reaction. So the first thing that we are going to do actually is to divide the equation into 2 half cells, or into 2 half equation. That is reduction half equation and reduction half equation. So it means that if you have the equation, first you need to identify which one undergo oxidation and which one undergo reduction, and then you split them into 2 half equation. So now let's start with the equation first. So now we have to know the oxidation number of chromium here and the number of chromium here. And that will give us the idea of how we are going to balance the equation. So how we are going to divide the half cell equation, or the half reaction. So now, this is chromium. Let's assume the oxidation number of chromium here is X. And of course, here we have 2 chromium. So we are now going to say 2 times X. We open bracket and close bracket, then plus. This is oxygen, and the oxidation number of oxygen is -2. We have -2 times 7, so we have 7 oxygen. So times 7, when you close bracket, and the net charge is -2. So everything here is going to be equals to -2. So we are now going to say 2 times x, then we have 2x, plus times minus is minus, then 2 times 7, we have 14, that is equal to minus 2. Then we now have 2x is equal to minus 2 plus 14, then we now have 2x is equal to plus 12. Then divide both sides by 2 by 2, then we now have x, we now have x equals to plus 6. So it means that the oxidation number of chromium here is plus 6. And then the oxidation number here of chromium is plus 3, already shown from here. So now we have this. So here, is it that the oxidation number increase or decrease? It's plus 6 here, and here is plus 3. So it means that the oxidation number decreases. Or you can say that there is a gain of electrons from here to here by the chromium. So therefore it means that this is the reduction half equation. So we are going to start with this. So now this is our reduction half equation. With our reduction half equation. I'll say reduction. And then without even checking and cross-checking, of course, this is oxidation, but we need to check how. So let's check the oxidation number of carbon here and the oxidation number of carbon here. So here we have, let's take the oxidation number of carbon here is Y. So we have 2 carbon. So we now have 2 times Y, we open bracket, then we close bracket, then plus. We have 5 hydrogen, and the oxidation number of hydrogen is plus 1. We now have open bracket plus 1 times 5, then we now close bracket. Then plus, the oxidation number of oxygen is always negative. So it's minus 2 times 1. And of course we have another hydrogen plus 1 times 1, that is 2. The net charge here is 0, so there is not charge. If you have 0, we have 2y plus times plus, so we have plus 5, plus times minus, we have minus 2, this we have plus 1, then is equal to 0. So we now have 2y is equal to 0 plus 2 minus 5. Then we now have 2y is equal to okay, so we have 2, okay, so we have this minus 1, so we have 0, so you have plus 1 here, so when we transfer it, so it's minus 1, then we have 2, which is going to change to plus, and we have minus plus 5, then it's now minus 5. So this one, I have minus 1, we have plus 1, then we have minus 4. So divide both sides by 2, so we now have y is equal to minus 3. So it means that the oxidation number of carbon here is minus 2. And what of in this case? It's CO2. So of course, carbon is x, so x times 1 plus minus 2 times 2 is equal to 0. So we have x is equal to plus 4. So the oxidation number of carbon here is plus 4. Is plus 4. So it means that the oxidation number of carbon from here to here increases. It means it increases. So there is a loss of electrons from minus 2 to plus 4. So it means that the ethanol here undergo oxidation. So it means that this is our oxidation half equation. So we now have C2H5 4H, then it is now going to give us CO2. So this is the reduction. This is oxidation half equation. Oxidation half equation. So now we have this. What is the next thing that we are going to do in balancing this chemical equation? So you see now, we're now able to demonstrate which one is oxidation half equation and which one is reduction half equation. So from here, the next thing that we are going to do is to balance the elements. Is to balance all number of elements here except hydrogen and oxygen. So we are not going to balance hydrogen and oxygen. So that one will come later after balancing other element. So you see here, from here we have the next step is to balance the number of elements. After dividing, so balance the elements except hydrogen and oxygen. So now we have Cr2 O7 2 minus, then we now have Cr3 plus. So now, how many chromium do we have here? We have 2 chromium. So we are going to add 2 here. So we now balance the chromium. And then for this one, we now have C2H5OH, then we now have CO2. So now, how many carbon do we have here? We have 2 carbon. So for we to balance the carbon, then we need to add here. So it means that the number of carbon and chromium are now balanced. Then now, what next? Balance the hydrogen. Balance hydrogen with balance hydrogen with hydrogen plus and oxygen with water. So it means that if we have hydrogen in the equation, so we balance it with hydrogen ion. And if we have oxygen, then we balance it with water. So you see that in this case, we have chromium 2O7 4 minus, then of course we have 2 chromium 3 plus here. So now we have oxygen. We have 7 oxygen here. So we have to add water molecule here. So since oxygen here are 7, so the best thing is to add 7 molecules of water. Because if you add 7 molecules of water, it means that the number of oxygen is also balanced. So we have 7 oxygen here, and we have 7 oxygen here, and we have 14 hydrogen. So then what next? So we now have the balanced oxygen. So how many hydrogen we have here? We have 14 hydrogen. So we have to add it here in the reactant because it is in the product. So we have 14 hydrogen. So since they are hydrogen, so we have to balance it with hydrogen ion. So therefore we are now going to have plus 14 hydrogen ions. So you see now the number of hydrogen and oxygen is now balanced. The number of hydrogen and the number of hydrogen and oxygen is now balanced in the first reduction reaction. Okay. So now let's take for the other reaction, which is C2H5OH. Then we have 2 molecules of carbon dioxide. So now the question is, how do you balance this? So now what we are going to do now, so to balance the number of hydrogen here, what do? We add hydrogen ion. So how are you going to add hydrogen ion? Now we have 6 hydrogen atom here. So therefore here we are going to add plus 6 hydrogen ion. But of course we have to balance the number of oxygen atom. How do you balance it? Now here we have, okay, so Let me just put here this one here. So we now have C2H5OH. So since we have 6 molecules of hydrogen here and we now add 6 hydrogen here, I think you can just simply add here, you can add 3 molecules of water. You can add 6 molecules of water. Yeah. Because the number of hydrogen that we have here is 6. So if we now add 3 molecules of water, then what will happen to the hydrogen here? What happened to it? So it means that since we now have 3 molecules of water here, so we have to change the calculation of the number of hydrogen atoms. So we now have 3 times 2, 6, and we have another 6 left. For 4 here is now going to be 4. Here is going to be 12. But do you balance the oxygen atom? Let's see. We have, because the reason why we add this water molecule here is because of this oxygen. Because here we already have 4 oxygen atoms. We have 4 oxygen atoms. So if we now add 3 molecules of water here, it means that we have 3 oxygen and we have 1 here, making a total of 4 oxygen atoms, which balance the number of oxygen atoms here in carbon dioxide molecule. So now based on that, we are now able to balance the number of hydrogen atoms. We are now also be able to balance the number of hydrogen atoms and then also the hydrogen ion. So it means that the hydrogen ion, the carbon dioxide, they are all balanced. So we have all balanced, the hydrogen atoms, the oxygen, and then the number of atoms. So what next? Is to balance the number of electrons. So how are we now going to balance the number of electrons? Then we are now going to calculate how many number of electrons are here and how many number of electrons are here. So we are just going to consider from here, we can see that chromium. From here we can clearly see that chromium. You can see that clearly here chromium has 2 minus. It has 2 minus and we have 14 hydrogen ion. So it's plus there. So it will have plus 14 electrons. So we have 14 electrons. So 14 electrons and then minus 2. So we have 13 electrons and we have minus 2. This will give us plus 12. So we have 12 number of electrons here. So we have 12 number of electrons in the reactant, while in the product here we have chromium 3 plus. Of course, the charge here is plus 3, then we now multiply it times 2, so we have plus 6. So the number of electrons in the product is plus 6 and in the reactant we have plus 12. So how are we going to balance it? By adding 6 electrons here. So we are going to add 6 electrons here. So if we add 6 electrons here, it means that this plus minus 6 electrons, because they already have plus 12, so plus 6 is going to balance the 6 electrons that are in the product side. So it means that by adding 6 electrons here, it means that in the product side, it means that in the reactant side, it means that it is going to balance the number of the electrons in the product side. So it means that now the equation is balanced for the reduction reaction based on the number of electrons. So it means that in terms of the number of electrons, in terms of hydrogen atoms, in terms of the number of oxygen, the chromium, the reduction reaction is now completely balanced. So 6 electrons are added in the reactant side, which balance the 6 electrons in the product side. So then the next thing now that we're going to look at is to balance the number of electrons in the oxidation half reaction. So now we have to know exactly the number of electrons we have for carbon here, and then the number of electrons that are here, so that's to balance the oxidation half equation. So to do that, actually based on what we have here, we have 0 electrons here, we have 0 electrons there, and of course here we have 4 atoms. We have 4 atoms. So to balance this 0, we have to add 12 electrons here. We have to add 12 electrons because everything here are neutral, so they are all neutral. So to balance these 12 electrons, 12 hydrogen ions that are added here, then we have to add 12 electrons. We have to add 12 electrons. So what is the next thing now that we need to do? So we balance the number of electrons both for the oxidation reaction and the reduction reaction. So what next? The next thing is to add the two half equation together, and then you subtract the common species. But before you do that, you have to get a factor that will make the number of the electrons in the oxidation half equation and the reduction half equation to be the same, so that at least they will nullify or they will cancel it. Like for example, the number of electrons here are 12, but the number of electrons here are 6. So how are you going to get a factor that after you add everything, the number of electrons here and here will cancel each other? So to do that now, we now try to look at a factor that you multiply your first, that is reduction reaction, that will give you exactly 12 electrons. So I think it's simple. So if you can actually add, if you can now multiply this equation by 2, if you multiply the whole of this equation by 2, I think it is going to give you exactly these 12 electrons. So this 2 multiplication will affect everything, in the reduction reaction. So let me just clean this and after we multiply, this one is now going to give us 12 electron plus 28 hydrogen ion plus 2 molecules of chromium manganese, which will give us also 4 chromium ion plus 14 molecules of water. And then we now take also this up here. So we now have, so this is what I just wrote here, 12 electrons. Your time to multiply everything here is going to give us 12 electrons, 28 hydrogen ion, 2 molecules of chromium for manganese, 4 molecules of chromium ion plus 14 molecules of water. After I multiply this equation, with 2, after I multiply it. So now the next thing is to take the order oxidation reaction, which is C2H5OH plus 3 molecules of water, which will give us CO2 plus 12 hydrogen ion and plus 12 electrons. So these 12 electrons will now make these 12 electrons, so they will cancel each other. And then let's look at the number of water molecules. So we have 3 molecules of water here. So this one will be cancelled, and then here we will be left with 11 molecules of water. And then what for the hydrogen here? So we have 28 hydrogen ion, we have a 12 hydrogen ion here. So therefore, this one will now reduce this to 16. Yeah, it will reduce this to 16. So we now have 16 hydrogen ion. So at the end, to have the final balance, redox reaction is now going to be 2 molecules of chromium ion plus 16 molecules of hydrogen ion plus C2H5OH, and then product we have CO2 plus 4 molecules of chromium ion plus 11 molecules of water. So this is the balanced redox reaction. So ladies and gentlemen, follow the step, and it's very simple and it's easy and you can do it. So now this is the balancing chemical equation in acidic medium. So in the next video we are going to look at how to balance the equation in basic medium.